Okay, so today in this video, what we are gonna do is we are gonna evaluate the sum using generating function. That this comes under combinatorial theory. Okay, so having assumed that you already know about OGF and EGF. That's OGF stands for ordinary generating function, and EGF stands for exponential generating function. So we are gonna use either of them in order to find sum of something. So basically these two can be used to find combinations and permutations, but apart from that we can find some other things also. So now before even moving with the problem, let me give you something about, now we are gonna focus our attention on EGF. Suppose A of x is the EGF of some sequence A0, A1, etc. and so on. This actually means that A of x can be written like A0 plus A1 x by 1 factorial plus A2 x square by 2 factorial and so on. So this is what we mean by telling A of x actually generates A0, A1, A2, etc. And if B of x generates the sequence, generates a sequence B0, B1 and so on, then B of x can be written as B0 plus B1 x by 1 factorial plus B2 x square by 2 factorial and so on. So this is what we mean by telling A of x and B of x being exponential generating function for some sequences. So now if A of x and B of x are EGF from some sequence, then A of x and B of x, it will be maybe if it is equal to C of x, then C of x generates, or C of x is an exponent generating function for some sequence, let it be C0, C1, C2, then this C0 or CR in general, CK whatever, the general term, it will be equal to summation. This is if I take I is equal to 0 to, it will vary from 0 to k, KCI, and AI BK minus I, BK minus I. So know that this will be the term. Moreover, we can tell, so A of x dot B of x generate a sequence where each term will be of this form. So if you want to know about this, multiply and you will get to know this. So this is convolution of these two generating functions. Have this in your, this is not like normal coordinate multiplications. So have a good understanding about it, and now we are gonna move towards a problem. So the problem is we have to evaluate this one, evaluate summation I is equal to 0 to r factorial divided by r minus I plus 1 factorial I plus 1 factorial. Yeah, so this is what we have, and as I told you, I'm gonna go for generating functions. Since I can either apply OGF or EGF, so here the first approach that I'm gonna use is EGF, because I'm looking at the factorial denominator and immediately I'm thinking of going for EGF, that is exponential generating functions. Okay, so before even applying exponential generating function, so let me just try an attempt or make an attempt to simplify this. This is so much of terms, no? This is the same term can be written like summation I is equal to 0 to r factorial divided by, so this can be written as r minus I plus 1 multiplied by r minus I factorial, and this is I plus 1 multiplied by I factorial. So now these three things, I'm sorry. Okay, fine. These three things together we can write as RCI multiplied by 1 by r minus I plus 1 and I plus 1. Okay, fine. Have this. So now we have simplified this one. Now we are gonna use exponential generating function in order to find the value of this. So now consider e power x. E power x it can be written like 1 plus x by 1 factorial, x square by 2 factorial plus etc. plus x power n by n factorial. So what is e power x? Then e power x is the EGF of what sequence? EGF of, look at the coefficient, 1 comma 1, this is 1 by 1 factorial you have to omit. Coefficient of x by 1 factorial you have to consider, that is again 1. This is 1 comma 1 comma 1 etc. So this is the EGF of this one. So I don't want EGF of 1 comma 1 comma 1 because I don't have that term. All I have to do I have 1 comma 1 comma 1 term like looking like this in the sum? No, right? So therefore I don't want just e power x. So I'm gonna do some modification. I'm gonna find first e power x minus 1. E power x minus 1 is equal to x by 1 factorial, x square by 2 factorial plus etc. plus x power n by n factorial and so on. So now what is e power x minus 1 by x? This is 1 plus x by 2 factorial, x square by 3 factorial and so on. So that is 1 plus x divided by, I can write this as 2 multiplied by 1 factorial. This is x square, 3 multiplied by 2 factorial and so on. So general term x power n divided by n plus 1 multiplied by n factorial plus etc. So now tell me the coefficient. This is 1 comma coefficient of x power r by r factorial in general. This is 1 comma 1 by 2 comma 1 by 3 and so on, right? So therefore this e power x minus 1 divided by x is the EGF of this particular sequence. But do I want this sequence? How do you know do I want the sequence? All I have to do is I have to look at particular term or rth term and I have to compare the rth term. Is the rth term in the sequence is same as the sum that I have? I don't have, right? So in the sum here I have RCI. It is a sum, but there I don't have a sum, and moreover it has RCI involved, and that here we don't have that kind of terms. All we have is 1 by 2, 1 by 3 and so on. So now I also know that e power x minus 1 by x is not enough right now. It is not the required EGF. So I'm actually thinking of multiplying the same term again, because we actually seen in the first part, when you multiply two generating functions, that is convolution of two generating function will give me something. Where each term is a sum of some, you can see this is each term ck summation I is equal to 0 to k kci. That is what I have. So therefore I'm actually thinking of multiplying the same thing again, that is e power x minus 1 by x, e power x minus 1 by x. This is e power x minus 1 by x the whole square. So okay, fine. So this is a generating function of 1 1 by 2 1 by 3 and so on, and this is a generating function of 1 1 by 2 1 by 3 and so on. So if you consider this as a of x, this is b of x, all you have to do is you have to find the convolution of two generating functions a of x and b of x. So this e power x minus 1 divided by x the whole square will be the EGF of some sequence. That sequence may be C0, C1, C2 and etc. Where here only we have to notice where each CR will be equal to summation I varies from 0 to R. This comes from the very beginning. I told you in the very beginning before we start the problem. You can go back and refer. Where each CR is equal to summation I varies from 0 to R. RCI a k b n minus k. So here a and b both are same, right? Both are same sequence. I can write this as a n minus k. Okay, so now, so look at the sequence here. What is the sequence we have? 1 comma 1 by 2 comma 1 by 3. That is what we have, no? So we have the sequence to be 1 1 by 2 1 by 3. So this is my a0, this is my a1, this is my a2. Can you notice the pattern? Then what is an? An is 1 by n plus 1, right? An is 1 by n plus 1. So now, so therefore this CR is equal to summation I is equal to 0 to R, RCI, AK is 1 by, is A not AK, we don't have any K, AI a r minus I. We don't have this kth term. All we have is I and r. This is 1 by I plus 1 multiplied by 1 by r minus I plus 1. So now you can see this CR is same as the sum that we are asked to find. Both are same. But now therefore which means that it is enough if I find the CR. What is CR? CR is nothing but the rth term in the sequence where e power x minus 1 by x square whole square generates. Or else we can say CR is the coefficient of x power r by r factorial in e power x minus 1 divided by x the whole square. All you have to do is you have to find the coefficient of x power r by r factorial in this particular generating function. So this is e power x minus 1 by x the whole square. So finding the coefficient of x power r by r factorial in this expansion is not a big deal. So you can easily do it. All I am doing is just expanding it. And yeah. So expand this. You have 1 plus 2x plus 2x the whole square divided by 2 factorial plus etc plus 2x the whole power r divided by r factorial plus etc plus 1 minus 2 e power x is 1 plus x square by 2 factorial etc. And also you have x square in the denominator 1 divided by x square. So finding the coefficient of x power r by r factorial will not be a difficult process, but you have to understand we have x square in the denominator. Therefore, you have to first look at the coefficient of x power r plus 2 in the numerator, so that eventually you get x power r in the denominator. But we don't want just x power r. We want x power r by r factorial. So you have to do some CAD simplification in order to get x power r by r factorial. So that will be the answer. The steps are very simple. You can do it on your own. So okay, so the idea is looking at some function. Think of if you have decided to go for generating functions, think of whether to use ordinary or exponential. So here I have decided to go with exponential, looking at the factorial terms in the denominator. I'm starting from e power x. I know what e power x generates, and from e power x I'm building step by step construction with the whatever elements that I want. I modify or add. Here I have subtracted 1 and divided by x, and even after subtracting 1 divided by x, all I'm getting the sequence 1 1 by 2 1 by 3 and so on. I know that the sequence is not the sequence that I want. I'm just finding the convolution of e power x minus 1 by x the whole square, that is x e power x minus 1 by x convolution with e power x minus 1 by x. So I'm getting the required sequence. Therefore, I'm actually finding the corresponding coefficient of x power r by r factorial. That will be the answer. So if you have any doubt, let me know. Thank you.